Hello students, today we'll actually be looking at organic chemistry, and particularly in organic chemistry, which is the chemistry of carbon, we're looking at reagents in what? Organic chemistry. There are three main reagents in organic chemistry. The first one is known as a free radical, the second is known as an electrophile, and the third is known as a nucleophile. And then we'll be explaining each and every one of them. Let us start with the free radicals. What are free radicals? Free radicals are actually electrically neutral atoms or group of atoms. They are electrically neutral. Now, the second thing about free radicals is that they possess unpaired electrons. They possess unpaired electrons. An example of a free radical is actually the chlorine atom. Let's look at it. It has 7 valence electrons with an unpaired. This makes it a free radical. So this is called chlorine free radical. Another example of a free radical is actually the methyl radical. Look at this. Again, this with an unpaired electron, and this is actually called a methyl radical. So like I've said, free radicals are electrically neutral and they possess unpaired electrons. Now we are done with free radical, and the second one is electrophiles. What are electrophiles? Electrophiles are actually electron-loving species, organic species. Now, how do we get that? From this word electrophile. Electro stands for electrons, while phile stands for philia. It means love of electrons. Now, since they are love of electrons, it therefore means that they must have an electron deficient center. They will have an electron deficient centers, meaning that they actually lack electrons. And that's the reason why they actually love electrons. Remember that like charges repel and unlike charges attract. Now the question is, what are the examples of electrophiles? The first example of electrophiles we have are actually positive ions, like hydrogen ion, the methyl cation, chloride cation. Now the second example of electrophiles that we actually have is what is actually called molecules with incomplete outermost electrons. Now when you have molecules that have incomplete outermost electrons, we observe that they actually act as electrophiles. Example is what is actually known as this boron trifluoride. And you can see that, look at this, look at the structure. Fluorine, fluorine, fluorine. Here boron is actually having 6 electrons, 2, 2, 2 for its octet. However, it's supposed to actually have 8, so it means that it has an incomplete octet. And because it has an incomplete octet, it's actually electrophilic, meaning that it's electron deficient. Another example is actually aluminium chloride. Another example too is what is actually known as iron tribromide. All these are actually molecules that actually have incomplete outermost electrons. That means their outermost shell is not completely filled. The next thing we look at is actually nucleophiles. Now the next one, like I said, refers to the nucleophiles. The word nucleophiles is actually a compound word gotten from nucleus and philes, philia. It actually means love of nucleus. So these actually are species that are electron loving. That are nucleus loving. Now, what does that mean? Remember that the nucleus is actually positively charged, so they actually like electron deficient centers. And if that's the case, it therefore means that they are electron rich. They're actually electron rich, meaning that they have sufficient electrons, therefore they are said to be electron rich. Now, since they are actually electron rich, they will love to react with the nucleus that actually lacks electrons, and that is why they always react with what? The electrophiles. So they constantly react with electrophiles. Now let's look at examples of the nucleophiles. The first thing is the nucleophiles are actually negative ions. Let's give examples. We have what is called the hydroxide ion, that's an anion. We also have the chloride anion. We also have the cyanide anion. These are all nucleophiles. Now the second example of nucleophiles are actually atoms or group of atoms with lone pair of electrons. Atoms or molecules with lone pair of electrons. Now, example of this is actually water. Water is a molecule and it actually has a lone pair of electron on oxygen. Now, another example is actually ammonia. It also have a lone pair. Now, you can see that if you draw the structure of water, and you can see that oxygen has a lone pair, and that makes it to be called what? A nucleophile. So I'll repeat myself. I said nucleophiles are actually nucleus-loving species. They're electron rich and they constantly react with electrophiles. Example includes negative ions, and the second one is atoms, group of atoms or molecules with lone pair of electrons. And examples include water and ammonia. Now we're going to be looking at the interaction between nucleophiles and then electrophiles. Let's see that.